Hi everyone, this is Zainab Zaytoun. In this video, I'll explain the second part of antiderivatives for grade 11. And as I said in the previous video, this is just a revision for grade 12. So also skim the video very quickly and see if you want to revise them or not. The objectives of this video is to define the linearity of integration, find the integrals of some functions using linearity, and find the antiderivative verifying a certain condition. And by the third objective, I mean how to find the constant of integration, which is c. And always remember to add c when integrating because most of the students forget to do so. Now, before defining the linearity of integration, let's recall together the linearity of differentiation. So suppose that you have a function f of x equal x power 3 plus 5x plus 2. How do we find the derivative of this function? Using the linearity of differentiation, we do the derivative of each term alone. So we differentiate x power 3 alone, 5x alone, and 2 alone. The derivative of x power 3 is 3x squared. Now, how do we differentiate 5x? Also, remember using the linearity of differentiation, if a function, which is in this case x, is multiplied by a constant, which is also in this case 5, then we just differentiate the function, which is in terms of x, and we keep the constant next to it. So the derivative of x is 1, so we're left with 5. Now for the third term, which is 2, the derivative of 2 is 0. So we're done. Now we will link it to the linearity of integration. Now, since integration is also linear, then we have these two properties. The integral of c f of x, c is a constant multiplied by another function, is equal to c times integral of f of x. So you take the constant outside the integral and you just integrate the function. Example, if you have the integral of 3x power 5, since it's a number multiplied by a function, then you just take the number outside the integral, so you have 3 integral of x power 5, and then you just integrate x power 5. And recall, to integrate x power 5, you add 1 to the power, and you divide by the new power, and of course, plus c. Now 3 and 6 cancels out to get 2. So from now on, when solving integrals, you can skip this step. So when you see this form, you see a constant multiplied by a function of x, you keep 3, and you integrate x power 5, so you get x power 6 over 6. So you can skip writing this step. Now another property, the integral of f of x plus g of x is equal to the integral of f of x alone plus the integral of g of x. For example, if you want to integrate x plus x power 5, then using this property, it's the integral of x alone plus the integral of x power 5 alone. Now for the integral of x, it's also of the form x power n. So you add 1 to the power and you divide by the new power. So x power 2 over 2. For x power 5, it becomes, as the one before, x power 6 over 6, and again plus c. Also here, as I said in the previous example, you can skip this step. So when integrating x plus x power 5, you should know that you need to integrate x alone to get x squared over 2, and integrate x power 5 alone to get x power 6 over 6. So you can skip this step, and here you can skip this step. Now I advise you to pause the video and repeat these two examples before solving this application. So this application combines both properties. Calculate the integral of 2x plus 5x power 7. So what do you think? How can we integrate it? So using the second property, you should think of integrating 2x alone and 5x power 7 alone. Now, how do you integrate 2x alone? Since here you have a constant, then you just put it and integrate x alone. So to integrate x, you get x power 2 over 2. So for 2x, you get 2 times x power 2 over 2. Now, do the same for 5x power 7. So you leave the constant and you integrate x power 7. You add 1 to the power and you divide by the new power. So you get x power 8 over 8. and again plus c. Now just simplify 2 and 2 to get this form. Now let's solve some exercises where we will use the linearity of integration. I advise you to pause the video and do them by yourself as we did in the application before. Now for the first one, the integral of 2x power 4 minus 6x. Using the linearity of integration, we deal with each term alone. So how do we integrate 2x power 4? Since we have a constant multiplied by a function, we keep 2 and we integrate x power 4. Since it has the form x to the power n, so we add 1 to the power and we divide by the new power, so we get x power 5 over 5. Now for this one, also minus 6x, we keep the minus 6 and we integrate x, and it becomes x power 2 over 2. We did it a lot before. Plus c for sure. Now, if you can simplify the fractions, you need to simplify them. So for example, for 6 and 2, you simplify them and you get minus 3. Now for the second integral, so we have the integral of 6 sine x minus cosine x. So also we deal with each term alone. We know that the integral of sine x is minus cosine x, and the integral of cosine x is sine x. So here you leave the 6, and the integral of sine x is minus cosine x, so you put 6 into minus cosine x. Then here you leave the negative, and you integrate cosine x alone, which is sine x, so you get minus sine x plus c. Now just put the minus before 6, so you get minus 6 cosine x minus sine x plus c. Now let's do the third together. The integral of 2x radical x. So from the previous video, how do we do these types of integrals? Whenever you see radical x, try to write it as x power half. So you get 2x x power half. Now since you have a constant which is multiplied by the function of x, then we leave the constant. So we're just concerned about this part, x times x power half. What can we do about this? Since they both have the same base, which is x, then you add the power. So you get x power 1 plus half, which is 3 over 2. So x times x power half is x power 3 over 2. Now, this has the form x power n. So we add 1 to the power and we divide by the new power. So we add 1 to 3 over 2, we get 5 over 2, and we divide by the new power, which is 5 over 2, plus c. Now we need to simplify it. So how do you simplify it? This becomes 2 over 5. Why? Because if you put the term in the numerator over 1 to be a fraction over 5 over 2, so you know that you should multiply 2x power 5 over 2 times 2 over 1 times 5. So you get this form. Then 2 times 2 is 4. Now, as we did also in the previous video, in order to get this back into a radical form, the number in the denominator refers to the index of the radical, and the 5 refers to the power. So since the index is 2, so it's the radical that you know, and the power of x is 5, so you get radical x power 5. Now how do you simplify radical x power 5? You can view x power 5 as x times x squared times x squared, and each x squared gets as x outside the radical, so you get x squared radical x. Or you can see it as x times x power 4, and then x power 4 gets x squared outside the radical, and you also get this form. More exercises on the linearity of integration. Now you should solve the first two easily by yourself, and the third one might be a bit tricky for you, so solve them alone. Now the integral of 6x minus 8, also we integrate 6x alone, so we integrate x alone and we keep 6 next to it. So we get, for x, we get x squared over 2, and we have 6. And for minus 8, so this is a constant, so remember that the integral of a constant is the constant times x. So we multiply 8 by x, so we get minus 8x plus c. Now we simplify 6 and 2, you get 3x squared minus 8x plus c. The second one, also, we think of minus 3 radical x alone and 2 cosine x alone. For the first one, we need to integrate radical x. So we know that we can't integrate it directly because it doesn't have any of these forms. So we change it into x power half as we did before. But this one can be integrated easily because we know that the integral of cosine x is sine x. So the first one, we need to write it as minus 3x power half. And for the second one, we know that the integral will become 2 sine x. Notice here that we were able to integrate this and we weren't able to integrate this first. So we keep this inside the notation of integration, and for this one, since we integrated it, we get it outside the notation of integration. So which is 2 sine x. And we leave plus c till the end. Now for this, now we can add 1 to the power and we divide by the new power. So we get 3 over 2 over 3 over 2. Now, as we did in the previous exercise, to simplify this fraction, you will get this form, and then 3 and 3 will cancel out. So you will get this form. For the third one, how can we do it? It doesn't have the form x power n, and it's not a constant, it's not trigonometric functions, so we need to change the form of this fraction. So what's the only way to change the form of this fraction? The only way is to split the numerator. So you get x power 4 over x power 3 minus x power 3, minus x over x power 3. So this is the reverse of the common denominator. Now for the first one, x power 4 over x power 3, simplify, you will get x. And for the second one, simplify, you will get 1 over x squared, since x cancels with 1x here. Now you can integrate x, but you cannot integrate 1 over x squared yet. So remember from the previous video, if it's in the fraction, you get it up to the numerator, but the sign of the power flips, so you get x power minus 2 instead of 1 over x power 2. Now it has the form of x power n. For the first one, x, you add 1 to the power, so you get x squared, and you divide by the new power. Same for the second one. You add 1 to the power, so minus 2 plus 1, you get minus 1, and you divide by the new power, which is minus 1. Here, minus and minus cancels out, so you get plus, and instead of writing x power minus 1, to get rid of the negative power, you take it again to the denominator, so it becomes x power plus 1, so x. And you're done. Now, this is the last objective of this video, is to find the antiderivative verifying a certain condition. Let f be a continuous function over I. Then, there exists on I one and only one antiderivative, denoted by big F, of small f, such that big F of x0 is equal to y0, where x0 is a number belonging to the interval I, and y0 is a real number. So what does that mean? If you have this condition, if you have a certain condition on the antiderivative, then you'll only get one antiderivative. So for example, determine the antiderivative, big F of x, of small f of x equal to 2x plus 3, such that big F of 0 is equal to 1. So here you have this condition. Let's start by finding the big F of x. So since big F of x is the antiderivative of small f of x, so we find the integral of 2x plus 3. So big F is the integral of small f of x, which is the integral of 2x plus 3. And this one is easy. So here you keep the 2 and you integrate x to get x squared over 2. And since 3 is a constant alone, so it'll be 3x plus c for sure. 2 and 2 cancels out to get x squared plus 3x plus c. But notice, since you have c and c can be any number, so this is not one antiderivative. We need to use this condition now. So in other words, you need to use big f of 0 is equal to 1 in order to find the value of c. So since big f of 0 is equal to 1, then what does f of 0 means? It means that you need to replace 0 instead of x. So instead of x, you replace 0, so you get 0 squared plus 3 into 0 plus c is equal to 1. So all of this is instead of big of f 0. This is 0 and this is 0, so you get c is equal to 1. So the antiderivative now is x squared plus 3x plus 1 instead of c. Now this is an exercise it's taken from Al-Ahliya book. Give an antiderivative f of the continuous function small f on the interval I and verify the given condition. So pause the video and do it by yourself like we did the previous one. For the first one, to find big f of x, it's the integral of 4x, and this one is easy. It's 4x squared over 2, and then simplify it, you will get 2x squared, and of course plus c. Now, we need to use the initial condition, or this condition, to find c. So the condition is that f of 1 is equal to 3. What does f of 1 mean? So instead of x, we need to replace it by 1. So f of 1 is 2 into 1 squared plus c is equal to 3. So this is 2, so c would be 3 minus 2, so it would be 1. Now let's write big f of x again. It will be 2x squared plus 1. Do the second one by yourself. So here, big f of x is the integral of x squared plus 2x minus 5. We integrate each term alone, so we add 1 to the power and we divide by the new power, so x power 3 over 3. For this one, you will get, you keep 2, and for x, it becomes x squared over 2, so 2 and 2 cancels out, you'll be left with x squared. For minus 5, since it's a constant alone, so it'll be minus 5x, and again plus c. Now we need to find c since we have a certain condition on the antiderivative. So we put f of 1 is equal to 1, it's equal to 0. What does f of 1 mean? So we replace x by 1. So you'll get 1 over 3 plus 1 minus 5 plus c is equal to 0. Now add these together, you'll get minus 11 over 3 plus c is equal to 0. So c is equal to 11 over 3. Now just plug c again here. So big f of x would be this. Do the third one alone. It's very easy and it's the same as the previous ones, and you should get this answer. That's all for this video. I still have only one part one topic for grade 11, so stay tuned until I post it. And after that, I'll be continuing this chapter for grade 12. And thanks for watching.